Hi, my name is Thomas Kim. In this session of video, I'm going to talk about tracking locations using Bison and Flex. Please visit this website and download source code and www.talkplayfun.com. Here, Bison and Flex. Scroll down, find reentrant parser and lexer. Download sample code. If you open the zip file, you can find resource folder and right-click, copy, and paste it to your working folder. Paste it and rename it Tracking Locations. If possible, do not use blank space in path folder, path name like this. Now start Visual Studio. Open the project, location and tracking locations solution. This is our sample previous project, and I will build and compile and run it. Ctrl F5. Okay, it is running. To understand, I will put a note here. I will add a few simple files, simple text files. Text file. I will name it Flex location, tracking location. It will be just a txt file like this, and I will add one more. You don't need to follow this. I am just trying to explain something. Bison tracking location txt. Okay, I opened two files. For location tracking, in Flex file, Flex input file will be lexer L, and Bison input file will be parser Y. I will use it underscore lowercase letter like this. Save it, save them. Here you have to define option YY line and O. If you want to use location tracking in Flex, you have to give this option. And in Bison parser input file, Bison input file, you have to give locations, these options. Also, if you want to use, I'm talking about reentrant lexer and the parser, so you have to give option Bison bridge. This is for reentrant parser. Also, if you are going to use reentrant parser, you have to give option reentrant. And also, if you are going to use location tracking in Flex, you have to give another option, Bison locations. And here in Bison, locations will be good enough. Then if we give these options in Flex input file, it will generate YY line and O it will manage right and O variables automatically. Also, if we give locations LO locations option in Bison input file, it will generate YY LLOC default. It will define YY L type. Some classes like this, or it can be like a struct or something like that. This file will be generated. This macro structure will be generated with these options. So let's see in our source code and lexer source code and Bison source code. I will move lexer code here. If we see Bison bridge and locations are used for reentrant parser and line number tracking or location tracking, we have to give this option here. And here parser input file, we have to give this option. This option is for location tracking. So in my previous video, I already prepared these things because I wanted to use this project as template for our future sessions. So location tracking is already prepared, and if we give this option, it generates. I open parser CPP file, then YYL type is defined like this, would be defined. It is automatically generated if we don't define it. So we usually don't need to change anything. So I will move it to Bison tracking. It will be generated like this with this file, with these options. And also, if we give YY location options in Bison input file, YY, this will also be YY LLOC default. This macro will also be generated. This is generated by default if we don't define YY or LLOC. So I will copy it, generated, and it is also generated. And another thing I need to mention is that each time here, this is rule action. Flex rules. This is matching rule, and each rule has its corresponding actions. Also, the same as in Bison parser file, each grouping, these are called grouping. Each grouping has actions. Actions are actually optional, but most of the time they have actions. So these are actions. This is Bison file, Flex file. This is Bison file. So each time this action, in case of lexer, each time matching is found in lex, then it executes one macro called YY user action macro is executed. This is macro. We will find it and here lexer generated file. If we search it, for example, YY user action is not defined, then it will be defined null. Then YY rule setup is defined YY user action. So I will look up this, copy and paste current document. If we search for this YY rule setup, then line 45, line 45, line 45 means this rule, this lexical analyzer rule. Before it is case is actually it is all handled with case. This is action. Actually, the code here I put. Before executing this rule, while rule setup is executed. Also, again, in case 2, line 59, before this rule is executed, this action is executed, while rule setup is executed. So while rule setup actually means while user action. Let's see. YY user action is actually YY setup. And so we can define YY user action to execute each time before the action in Plex is executed. In the same manner, in YY pass, this YYLLOC is also executed before each action. I will find it. So this is executed. This is let's try another one. For example, this is executed, and these YYLLOC default is actually executed before each action. Before each action is executed, this is action and this is rule and grouping rule. This is called before each action is executed, YYLLOC is executed. In summary, in Plex, YY use action is executed right before action matching action is executed. In the same manner, Bison track in case of Bison, each YYLLOC default is executed right before its grouping action is executed. So YYLLOC default corresponds to YY user action in Lex. So you have to understand these two relations between YYLLOC default in Plex input file, Bison input file corresponds to YY user action in Plex input file. So you have to understand this relationship. So if we change these two actions, we can easily track line numbers. This is the theory. Before we do that, I will make some changes to both Plex and lexer. First, I will make a simple calculator. Then, first I will change it SMT INTZ like this. SMT INTZ. I changed it. It's semantic type. I would SMT means semantic type. So this should be updated like SMT like this. Also, it should be changed to a couple of more places. So let's try. Let me see here. It should be changed to like this again. I will also rename it like EXPLINTZ like this. Then save it. Then scroll down. It should be changed to INTZ. Also, it should be update it to intz, and that's it. Let's try and rebuild. We have error message. Let's see here. 109 here. expr int is invalid expr. This is wrong. intz, of course. Then build again. intz here, lexer, and we have to change 59 lexer 59 here, 59, no, not 59, this one, it should be smt intz. Okay, let's build it again. Okay, it's working. Now I will make more changes. I will change this carriage return new line character to semicolon. So I will change all occurrence of new line with a semicolon like this. Then I change it to parser y. Then I will also make changes to here. Here I disabled it. I will create another one, OPRS. OPRS means operator. I will create a star at asterisk slash plus semicolon minus, also I will add parentheses. Please note that the last character enclosed in square bracket should be minus. You should not put minus at the beginning like this, okay? It should always be at the end like this. Then I will put one more like this character. Now save it, and we don't need it, so we don't need to return it anymore. So I will save it like this and save it. Now I'm going to return this operator here, second line, OPRS here, sorry, here I will say return YY text 0 like this, and save it. Now I'm going to, let's try and build. Okay, it's running. Now I'm going to turn it to a simple calculator. In this session, I'm concentrating on line tracking, but we need to try some testing, so we need some more code. I'm going to make it a simple calculator. Here, bar expr intz plus expr intz. Then I make $$1 plus $3. I made simple changes like this. I will copy this line of text. Here I will change it to minus, and it should be minus. I will change it to star. Then I will change it to star. Then I will change it to slash. Then I will change it to slash. Now I'm going to change it to power, and I can't use like this. This is int, so POW double and double, sorry, here, save it, and here I will remove it for the time being, like this. And we need math function for this, so I need to include here INCLED CMS. Okay, now I need to define about debugging. I will talk about debugging for Bison and Flex in some other sessions. Right now I will not talk about debugging anyway. So here we need to define operator precedence like this. About operator precedence, please read PDF manual, Flex and Bison PDF manual. And okay, we defined, right? I defined, and I will do like this anyway. Save it, save them. Then we can execute them. Now let's build and try. Rebuild. Say 96, 96, 90. Left, sorry, it should be percent. Also it should be percent. Now save them. Rebuild. Okay, it's built. We made a simple calculator, but I want to add one thing more, like operator precedence for unary operator. Precedence unary OPR unary minus. I would say unary minus like this. Then here we are going to add an unary operator minus expr intz like this, minus the $1. Here we have to say prec unary minus like this. This is unary minus. Then I will add one more. This time this will be unary plus like this. Then we don't need it. I made the mistake here. It should be 2, not 1. It should be 2 because this is 1, this is 2. Instead of unary minus, I would say unary operator, OPR. OPR means operator. I will change it. Okay, let's save it. Now I want one more changes, one more addition for parentheses, expr intz. Then action will be 1, 2, $2. I fixed like this. Now our template is made. Now let's try this calculator. Double click, build. Okay, now let's run. 5 plus 5. Okay, 10. 2 plus 2 times 2. Okay, 2 power 3. Sorry, 8. Okay, it's working. 2 minus 2 power 4. Okay, it's working. So let's close it. We made a simple calculator like this. Now I am going to concentrate on location tracking. As I mentioned here, this code YY use action will be automatically is executed right before matching rule is executed. In lexer, these are matching rule. So to do location tracking, also I said that this data structure will be defined, will be generated by default if we don't define YYL type. To do that, to use location tracking, I will go to here, YY pass. In our previous sessions, I will define here public int no columns. I inserted and defined a new variable, member variable like this, and I will initialize it in the constructor. It's true, I initialize it. Then I will use it to track columns. For this purpose, from here, as I told in my previous, if you haven't watched my previous video, please watch it. I will put the link in the comment section below. Here we can access this member variable. We can access in lexer using YY extra variables. So we are going to define not this one. We are going to define this like this here. YY here, code section. I will put it here like this. define. This code will be executed each time. We can access this variable. Like this, YY extra. Before I do that, each time new line is matched, YY extra m columns will be set to 0. I will set like this. Then here YY extra no columns, I will add like this YY leng. YY leng contains YY leng is the byte length of the YY text. So, and then we will change YYLLOC. YYLLOC is this data type. YYLLOC is YYL type. Okay, it is automatic. It will be passed to YYLex, and I will change it first. This first line to YYLLOC last line. I am making these first line and last line the same. Then I assign YY line NO. YY line NO is generated. This is actually macro in reentrant parser. For example, if we define option YY line NO, then this YY line NO will be generated and managed by Flex. this contains the line number, current line number, scanning line number. So it is managed automatically with this option in Plex, in Lexer. And then YYLLOC, first column, ULUMN, I will define YY extra NO columns like this, minus YY LNG plus 1. If you if you are not sure, for example like this, then don't worry, we can try it. Then YYLLOC last column, then it will be simply YY extra NO columns. I will define like this. Here we defined this macro we defined. Okay, let's run it, save it. I will explain more about these things. YY extra, we use YY extra column and YY extra column, YY extra column. I will talk more about this in a few minutes later. Okay, we will rebuild. Okay, we have error messages like this. Here, if I scroll up, it says syntax error and LLI here. Syntax error, something like semicolon is expected. Then, what does it mean? Okay, let's go back. This YY user action, I copied it, then open it, find it. Let's find it. YY user action actually means YY rule setup. YY rule setup is defined to YY user action. I copied again. If you see this code of text, after case statement, there is no semicolon here. YY rule setup, there is no semicolon. So we have to change it to semicolon like this. Okay, so I save it and run it. Build again. Here I made a typo here. MCOLUMN. Let's see. So it is not M, it is NO. So I will change it to M. I saved it and I save it to M. I changed it. Also here I will change M and where is M? Okay, M. I changed and I build again. Okay, everything built. But before I go any further, I will change it to, I will bind it to with the curly braces. So it's better, right? I saved it. Now I build and run. Rebuild and run. Okay, Control F5. It executes as expected, but we cannot have a line number here. To change that, to put line number, to display line number, go to this file and scroll down. Here we are going to change it, error, here. I will display line number here. Now let's see. YYLLOC is transferred passed to YY error here. YYLLOC first line, then no, I will use this mark, then YYLLOC last line, then it continues like this. YYLLOC first first column, then YYLLOC last column, then I have changed like this. Sorry, I have changed like this. Save them. Now run them. Run again. Okay, built successful. Now Control F5. For I make a syntax mistake on purpose. Then it gives line 1 from line 1 to line 1 2 minus 3. 2 minus 3 means expected semicolon, expecting integer or plus or minus or something. It means something is wrong here. This is actually causing the error here. So 1 2 3, this should be 3, and the first line is 2, so we have to change it. Let's see here, the first column, last column. So first column should plus 1. I added it 1. Now rebuild. So we learn it all works properly. See, it's working. But we want to make mistakes like this. Is syntax error. Then it gives line 3 from line 3 to line 3, 5 from character 5 to character 5, 1 2 3 4 5. It means semicolon, unexpected semicolon. So semicolon's place is properly displayed. This is column, this is line, from column 3 to column 3. So this line tracking is properly executing. So this way we can implement line tracking in Bison and Flex. In summary, if we want to use line tracking in Bison and Flex, in Flex we have to define this option, and we have to make changes to YY user action. We defined YY user action like this here, and YY user action is executed right before matching action is executed. Also note that YY actions should end with a semicolon. It should end with a semicolon like this. YY rule setup is actually YY user action. It does not append semicolons here, so we should put semicolons here or make it like a block of code. Now I'm trying to concentrate and I am trying to tell you one thing more. Here Bison, I said YY lock default is executed right before each grouping and action is executed. So I will try this one now. From generated a file like this, we find yy LLOC default DE. Here we found it. It is generated. Now I copy like this until here. Copy it. Then go to move up to here. I will put it here like this. Then I would remove it like this. So like this. I will keep going. This is the end of our macro yylock, yyLLOC default. I will make it a semicolon like this. And I put some display message, for example, std, cout. Then I will simply use these. Like this here. Like this. Then it will be last line. And I need a semicolon slash. Now I will keep it going like this. Then last line. Then I'll copy these. First column. This is last column. Then I will close. I will do like this. Let's try it. First, last line, first column, last column. Let's try it. Rebuild. So we have error message, syntax error. Let's see. I think it is causing the trouble. Here. Let's double check. Here. No, we repeat it twice. Okay. Succeeded. Control F5. Now it gives the details like line 1, these are all in line 1, first column, third column, first, second, third column, It is giving details about the progress, for the result is 9. If we want to control these, for example, you can put here, I would say if yy debug is 1, yy debug is actually we tried it here long before in our previous session. In reentrant parser sessions, I explained about yy debug here. So to use yy debug, you have to put options parse trace to enable runtime tracing or debugging, you have to give define parse trace option. About this option, I will talk in some other future videos, not right now. So if with this we can change some code here like this, then we can run it, build and run. Was the error? Oh, I made a mistake. I have to put semicolon here like this, then run it. Control F5. It works as before, but debug on. If I give option debug on, then it gives detailed tracings. These are line numbers, line number, column, state. It gives all details. For example, how these are passed. All details will be displayed like this about the operation, how Bison passes the text. So how this token is passed is all steps are detailed like this. These are line numbers, column, line number, column like this. So about the debugging, I will talk in some other videos. For the time being, we turn off again. Then it works as normal. Like this, it works as normal. About debugging for Bison and Flex, I will talk in future videos. Thank you for watching.